Stuff that we actually can do, that is interesting, it really is. But stuff that we can actually do some things with. Specifically, we're going to get into some curve sketching, which I know it doesn't sound really cool because you can kind of do it on a calculator, but this will lead you to understand why curves are the way they are and why they're shaped the way they're shaped. A calculator won't let you do that. So we're going to start section 3.3, tell you something about the first derivative of text. Some of you are already signed because you just realized we finished 2 sections, right? Yeah. This is our 3rd section, and it's going to go very fast. You don't have to throw your calculator down in anger, all right? You don't have to do that. Recall something for me. We just did this like, well, on the video it seems like only 20 minutes ago, but actually it was on Wednesday. What does this mean?
The first derivative is greater than 0. I don't know. I don't remember this from before.
First derivative. Okay, it's a first derivative and it's positive. Greater than 0 means positive. You're both right. What's it mean? No. Oh, no. I burned your
Oh, it's a positive slope.
paper for that. Hand you back your staple.
Or it's increasing. Yeah, concave out.
Has nothing to do with concavity.
Yeah, well, it is increasing.
Nothing to do with concavity. At all.
Slope is
First
increasing.
derivative has to do with the slope or
Curve?
that's the rate of change of your line. So it would tell you increasing or decreasing. That's what it would tell you. So those of you who said increasing, decreasing, you're right. Concavity, no. That's second derivative. Okay. Second derivative tells you how the slope is changing. So you need a second derivative to do that. No, that says the slope is positive. If slope is positive, you're like this, right? What's your line doing? Going up or down? Increasing. This says increasing. Understand? Refresh your memory on 3.1 if this is like, oh my, the first part of 3.1. What's that mean? Definitely decreasing. Slope is negative. First derivative negative. Slope is negative. Decreasing. Aha. What's this mean?
It's a constant. Straight line.
That would be a horizontal tangent. That would be finding critical numbers. Constant or critical numbers. Or critical points if you prefer. I think they switched to critical numbers because technically x equals a value isn't quite a point, is it? It's just a number.
What are critical numbers again? I don't want to go back in the video. Oh, it's where the rate of change of the slope changes. So like when it goes from increasing to decreasing, that's it. Yep, I remember.
Now, I'm going to tell you how
Or
to
decreasing,
find
increasing. Either one.
relative extreme. You think you already know because you know what critical numbers are, but I'm going to give you a nice graphic. You have all the information. Okay, I'm not going to teach you anything really new. You have it all up here. You have it on your notes. What I'm going to tell you is how to do it properly. I'm going to give you a graphic organizer so that's a little bit easier for you. Would you like that? Here, and do this on your homework. This is how I want you to do it. How to find a board. Oops.
I can't anymore.
That cannot. Girlfriend watching this? Kidding. She hates math, so I'm in love. It's horrible. How to find relative extrema. Here is what you're going to do. You're going to do something called the first derivative test. That's what this is to do. So, first derivative test says, first derivative test.
Relative extremum is either a relative minimum or a relative maximum. Plural of extremum is extrema, and similarly for maximum and minimum. Because a relative extremum is extreme locally, by looking at points close to it, it's also referred to as local whatever. Okay, so it's max or min. So you're finding these. And it's just only on that interval. Okay.
Number one, take the first derivative. We're so original in mathematics. Take the first derivative. That has to do with the first derivative test. Number two, set it equal to 0 for your critical numbers. Number three, you're going to make what I like to call the first derivative table. Here's what the first derivative table looks like. You're going to draw a number line. This is a number line. It's just it's a way to organize your graph, okay? Because ultimately, just to give you like an advanced organizer, we're going to be graphing functions. So this is the first part in graphing your functions. It's just organizing it for you, so this is going to be a graph. What goes on the top of your little graph here is your first derivative represented by your critical numbers. So you put your critical number 1, critical number 2, and so on until you run out of critical numbers. They have to be in order. So critical number, critical number, critical number. However many you get. There might be 0, there might be 1, there might be a dozen of them. Doubtfully a dozen. So take the first derivative, no problem. Set equal to 0, we've done that already. We found critical points, that was 3.1. Make that table, that's something new, but it's not very hard to do. Then what we're going to do for our table, step number 4, I'm just redrawing here. Listen. You know that at this point, and however many I have, your first derivative will be 0, right?
Yep.
And that's telling you have a horizontal tangent. So, before that, note that you're going to either be increasing or decreasing, right?
Yep.
After that, you're going to be either increasing or decreasing. After that, you're going to be you are either going to be increasing or decreasing here, and increasing or decreasing here, and increasing or decreasing here. If you weren't, then it would have shown up. You follow me? It would have been there. It would have been a critical number. It would have been saying, oh, my slope's 0. So if those are your only numbers, you must be either...
So we're going to plug in a value before or after. or before and after, see if it's positive or negative. Kind of like the sign
Increasing or
analysis.
decreasing. So step number 4, we test a point in each of those intervals. It's so much like a sign analysis test, only you do it in the first derivative. And that's going to tell you, because the first derivative gives you increasing or decreasing. If you're positive here, are you increasing or decreasing?
Increasing.
Increasing. If you're negative here, what are you?
Decreasing.
So, and if it changes, you know you have a max or a min. If it doesn't change, you know you don't have a max or a min. Does that make sense to you? That's our whole idea. So for each interval, you're going to plug in a number into your f prime of x. I'll say it this way. Find the sign of each interval by plugging a value into f prime of x. Not f of x, that'll give you points. We want slopes. Why? Because this will tell you increasing or decreasing. That's what we're looking for. Some of you are zoning out. You got to be with me on this stuff. Because this tells you increasing, decreasing. Okay, I only have 2 examples because this is pretty much self-explanatory. I mean, you've done all this stuff. You've taken first derivatives, right? That was what this whole class was until this point. You know how to set them equal to 0. That's algebra. You know how to plug numbers in. That's algebra. So that's it. I'll show you a couple of them, but really the idea is the same for all of it. Just be aware that what I told you about rational functions still stays the same. To find critical numbers for your first derivative, the 0, when you set equal to 0, just look at the numerator. Now, what we are going to discover is that you also have to use those denominator numbers for your tables. We'll get there later on. I'll show you why that is the way it is. But maybe I'll show you now. I think I might have one of those examples. But you also have to use those for your first derivative and second derivative test because things can happen there. For instance, if you have an asymptote, sometimes functions look like this, right? See how that changes from increasing to decreasing? But that number's not going to might not show up on a first derivative test. So you'd have to put any places where you're undefined from your original function on that, because you could change from increasing to decreasing there. So we'll also be doing that. So look for critical numbers.
Crap, I wasn't paying attention. None.
Your first derivative and second derivative test, because things can happen there. For instance, get there later on. I'll show you why that is the way it is. You know how to set them equal to 0. That's algebra. You know how to plug numbers in. That's algebra. So that's it. I'll show you a couple of them, but really the idea is the same for all of it. Just be aware that what I told you about rational functions still stays the same. To find critical numbers for your first derivative, the 0, when you set equal to 0, just look at the numerator. Now, what we are going to discover is that you also have to use those denominator numbers for your tables. We'll get there later on. I'll show you why that.
For the tables. Not sure what he means.
That's the way it is. But maybe I'll show you now. I think I might have one of those examples. But you also have to use those for your first derivative and second derivative test because things can happen there. For instance, if you have an asymptote, sometimes functions look like this, right? See how that changes from increasing to decreasing?
Yeah, but it's not a
But that
max.
number's not going to might not show up on a first derivative test. So you'd have to put any places where you're undefined from your original function on that, because you could change from increasing to decreasing there. So we'll also be doing that. So look for critical numbers. Maybe I'll make a little side note here. Also put any undefined values. So basically asymptotes. Put any asymptotes. Okay, we're going to do the first derivative test here. So first thing, what are we going to do for our first derivative test? Why don't you tell me?
Whoops. Alright, try this my own. So we got 3x squared minus 3. Find the critical numbers. There's no denominator, so no asymptotes. 3x squared equals 3. Divide by 3. X squared equals 1. X equals 1 or negative 1. Put them on this number line thing. Oops. Plug into the original function f prime of x, or f prime of negative 1. Okay, it's gonna be the same thing. Because we got a x is being squared. So this is 0. What is this, what's the point of this? F prime of 0 equals negative 3. So we're going from a or wait a minute. No, we plug this into plugging in the f prime. Is it f prime of x we're plugging into? We already know it equals 0. Oh wait, it has to be negative 2, not negative 1. Yeah, crap. That's why I got 0. So 12 minus 3, that's 9. And then you have 0, negative 3. And then 2. It's still 9, it's positive. So positive, negative, positive. So we're going from increasing to decreasing to increasing. So this is going to be the max relative max. Relative, or this was gonna be the absolute max, I think.
Do it. I gotta warn you, I will warn you, some of the ones in the homework there, worst derivatives, of course. I don't have the time to do expansive just derivatives. I've already done that in this class. That was for the first chapters, all right? But the ideas are the same, okay? If you need more help on those derivatives, you come and see me, check out the previous videos you can. Make sure you know how to take those. What are we gonna get for our derivative? And what do you do with
That
that?
square. Yeah, okay.
And what do you do with that? Factor the 3, factor x squared minus 1, add the 3, divide by 3, take a square root with plus and minus. I think we've seen this like 3 times in this class, actually. X equals 1 and negative 1. You okay with the 1 and the negative 1? Hey, quick question. Are there any other points that would make this undefined?
No.
Any denominators? That's what we're really looking for, any denominators, okay? That would give us asymptotes. So if there's no denominators, then those are the only 2 points I'm going to have in my first derivative test. Here's how you make it up. You're going to put f prime of x. You're going to make this line slightly below f prime of x. It doesn't go right after, it goes slightly below it. And the reason is, I'm going to give you another piece for down here. So we're going to fill out the second piece in the next section. On the top, this works for your f prime of x. You're going to put your critical numbers. There's only 2 of them. So we make both numbers. What are my 2 numbers? They have to go in order. Would you agree that those are the 2 points where my slope is equal to 0?
Yep.
Everywhere else, this is also continuous everywhere, you're either going to be increasing or decreasing. How we find that out? We take a number here and we plug it in. When am I going to plug in a number here? To the function or to the first derivative? In this case, the first derivative. That's why I have a first derivative right there, right? That says I'm talking about increasing and decreasing. Once you do that, pick an easy number. Pick like negative 2. Plug it into your first derivative. So if I were to do this off to the side, I'd do like, okay, I'm plugging in f prime of negative 2. This one I definitely would pick 0. This one I'd probably pick f prime of 2. And I would plug those things in, and I don't care about the actual number. I care whether it's a positive number or a negative number. That's what's telling me what to do here. So plug in negative 2. If I plug in negative 2, I get, I don't know, something big minus something small. Positive. You get positive 9, right? I don't care about 9. I care whether it's positive or negative. That's the key. Plug in 0. I get 0 minus 3. What's that? Negative. Don't care about what the value is, just positive or negative. How about 2?
Positive.
Positive. What's my function going to be doing in this interval? Increasing or decreasing?
Increasing.
Why would you say that?
Positive.
Slope. This is a slope, right? You plugged in a point. This is the only places where the slope could possibly change, right? That's it, because you found the zeros. So it's going to be consistent for those intervals. So this says my slope is positive. That means my function is increasing. My slope is negative. That means my function is decreasing. My slope is positive. That means my function is increasing again. Hey, are these relative extrema?
You know, I don't think this would be an absolute max. Because it's increasing again after. Yeah, I'm not going to say that. Wait, this would be a relative max though, wouldn't it? Increasing, decreasing. So it'd look like this. Go like decreasing. This would be a relative min.
Which one would you say this is? A relative max or min? Think about what the function would have to do to get that. What would the function have to do? It'd have to climb and then fall. What is that? Just this part, just this part. That's a max. Climb, then fall. What's this one? Fall, then climb. Do you see what I'm talking about? So we know that right now, because of this, This is going to give us, we don't know what it is exactly because that's just the x value, but we have to plug in and find the points. That's going to give us a relative max. This one's going to give us a relative min. Would you tell me how I find those points? How would I go from here to actually getting the, because right now I just have the x, right? So I know my relative
Just plug it into the original
maximum
function.
is going to happen.
Zero, zero.
At -1 comma something, right? And my relative minimum is going to happen at 1 comma something. How do I find the somethings? Not my slope function, not my first derivative, because that would give you 0. That's how we found them in the first place. But my original function, if I take these and plug them into my f of x, f of -1, f of 1, what now? No, that was
That's the
the
original
slope.
function.
That's right.
So original function, plug in -1 here, you get -1 plus 3 plus 1, what do you get, 3?
Yeah. Oh, I plugged it into your. I plugged it into the derivative. Okay, so that's 3. It's gonna be the same thing. Or no, it's a cubed. It's be 1 minus 3 plus 1, -1.
Do the minimum. 1 minus 3 plus 1, -1? I hope I did it right. Doing fast. So, can you tell me what's the relative maximum? What's the actual relative maximum? 3. Where does it occur? At the point -1, 3. Do you understand the difference? What's the relative minimum?
It's the y values of height. Yeah.
It happens to occur at the point 1, -1. Are these absolute maximums and absolute minimums?
It's relative.
I haven't even given you a close, right? And this is a polynomial that looks like this. That's what this does. It goes up, down, up. There's no absolute maximum in, but there's a relative maximum, there's a relative min. Those things are important.
If I have the absolute when you have a set.
Closed. When it's closed, you will definitely have that.
But that's the only times when you have an interval.
No, we could have x squared, down, up, right? So you really have to know the polynomial you're dealing with. We'll try one more of these next time, but do you have the understanding of what this kind of goes on? How many people feel okay with this so far? All right. Okay, so moving on, we're still talking about first derivative test, and what the first derivative test says is can you find critical numbers and determine whether or not they are relative maxes and relative mins. How to find critical numbers is the same old thing. We're going to take a first derivative, we're going to set it equal to 0, and we're going to solve it. So, take your first derivative of that thing right.
That's not fun to do. 5x 2/3 minus 10x -1/3. I want to make sure this is right before
There,
I move
and
on.
set it equal to 0 for me. Would you do that for me real quick? If you haven't done that already, go for it. What'd you get?
5x 2/3 minus 10x to negative 1/3.
5x 2/3. You all got 5x to 2/3? All right, minus. You said what now?
10x to negative 1/3.
Good.
Okay, that's what we got. It said equal to 0. Find the slopes of 0. I guess. 'Cause they're not extrema yet. Factor out of 5. This is annoying.
Show of hands, how many people got that? Good deal. Now, that right there is our slope. Of course, that's our first derivative. When we set it equal to 0, we'll find the places where the slope is 0, or a horizontal tangent line. Those are defined as our critical numbers. So we have this set equal to 0. So far, so good. Now, how do you solve that?
Factor out of 5x to the negative 1/3.
Factor out the 5x, very good, and you choose the smallest power, not the largest one. The negative
that's- I
1/3.
gotcha. Forgot. That's what we divide by negative 1/3. Negative 6, 3, negative 2. Minus 2x. This is 1, so. I think this would be the same thing that I got before. Wait. Okay, I'm confusing myself now, I guess.
One factor. I think I showed this to you one time before, right? So we will factor out the 5x to the negative 1/3. What you end up getting, factoring means dividing, dividing means you're subtracting exponents. Check it out. You've got, well, 5x to the 2/3 divided by 5x to the negative 1/3. There's no more 5. X to the 2/3 minus negative 1/3 is x to the first power. Did you get x to the first power? Not 1/3. First power. The first minus by 5x to the negative 1/3. There's no more 5. X to the 2/3 minus negative 1/3 is x to the first power.
Huh?
So we will factor out the 5x to the negative 1/3. What you end up getting, factoring means dividing, dividing means you're subtracting exponents. Check it out.
Oh. Like you're dividing, okay. be like you're doing 5x to negative 1/3 over x. Wait, this is all wrong. You're dividing 5x to negative 1/3. No, 5x to 2/3 divided by 5x to negative 1/3. Like that. This is wrong.
You've got, well, 5x to the 2/3 divided by 5x to the negative 1/3. There's no more 5. X to the 2/3 minus negative 1/3 is x to the first power. Did you get x to the first power? Not 1/3. First power. Yes, no? Yes. Minus. What happens if I factor out 5x to the negative 1/3 there? How much do I get?
2.
Cool. That's the correct factorization. If you want.
Oh, wait. How'd they get 2/3? Because I added them. Oh. Jeez. So that's the only point? We didn't do on the denominator. This one sucks. I don't even know what this would be.
Check your work, you distribute, you see you had the right thing. How many people were able
I
to
don't feel
find
like going along with that because I think I'm wrong.
Good, very good. Now, can you verify something for me real quick? Can you verify that we actually have a denominator on this problem? Why do we have a denominator on this problem? Aha. So really what you have, this is not on the numerator. In fact, what you have is 5x minus 2 over a cube root of x. Can you see that? Now here.
Oh, I hate this problem already. When x equals 0, I could have done that actually without plugging that in. We're setting it equal to
Here's
0.
one thing I was talking about. We're at the point right now where we can make our critical numbers, where we can find those things. But there's one thing you got to realize. Whenever you have a denominator, the value that makes your denominator equal 0 also has to be on your critical number. Does that make sense to you? It's got to be there. Even though that's a denominator, and some of you might go, oh, well, zero product property, right? Because you have something times something equals 0. Well, yeah, that's true. But realize what this is. This is actually 1 over the cube root of x. You follow me on that? That's why I'm giving it to you this way, so that when you come up with your problems, you get the right critical numbers. So let's go ahead and make our first derivative test. Remember, that's the table. And on our table, we're going to do critical numbers. Critical numbers occur where the function is equal to 0. In our case, x minus 2 equals 0. And where the denominator equals 0. Now, that's going to be an undefined point for our slope, but it might change, increasing or decreasing, something like that. So we'll also have the cube root of x equals to 0. Ladies and gentlemen, raise your hand if you feel okay on getting those points. So where the numerator equals 0 is where the function will equal 0. Where the denominator equals 0 is going to be some undefined points for slope. Right? That could be the case. So we need to have that up here somewhere. We have interesting things that happen there. Well, let's go ahead and do that. We're going to get x equals 2. We're going to get x equals 0. We'll have some critical numbers. Now, something may or may not happen here, but it might. How many regions do we have? Regions.
3.
So we're going to check a point in each of a number in each of those regions. This one you'd probably pick -1. This one you'd probably pick 1. This one you'd probably pick 3. So let's check those. Now my question is, where do I check them? Do I check them in my original or in my
Derivative.
first derivative? Original will give me points. First derivative will give me slopes. The slope will tell me increasing or decreasing, which is what I'm looking for. You remember that this is supposed to give increasing, decreasing, right? So do I plug it in my original, which gives me points, or my first derivative, which gives me slopes? The first derivative. That's why it's called the first derivative test. So take some numbers here, f prime of -1, f prime of 1, f prime of 3. And we're plugging it into, well, the first derivative, because what I know is that if the slope is positive, I'm increasing. If the slope is negative, I'm decreasing. That's what we want to find out. Excuse me. Hey, when you plug in -1, what do you get? You get a positive number? Okay, because we have a negative number over a negative number, that's going to give you a positive number. Did you get that as well? So I don't care what the value is, as long as you know it's positive, that's going to be a plus. Are you with me on the plus? Let's plug in 1. When you plug in 1, do you get a positive number or a negative number? Who got negative? You got negative? Anybody else get negative number? Are you seeing, I'm getting a lot of people who aren't saying anything. Are you getting where the positive and negative are coming from? Okay, negative, very good. We get negative over positive, that's a negative. When you plug in and try that on your own, plug in the 1 here, you're going to get -1 times 5, that's -5, over +1, that's -5, that's a negative. Still okay? Plug in 3. When you plug in 3, you're going to get a positive times a positive, that's positive, over a positive. Cube root of 3 is going to be positive, right? I don't really care what it is. As long as it's positive or negative, that's going to be a positive. Show of hands, how many will feel okay on the plus minus plus? Do you see why the 0 was important there? That's pretty important, right? It shows you a change. Even though this was on a denominator, you had to have that. So you got to have that as part of your critical numbers. It can show a change between increasing and decreasing. Now, what do all these things mean? The plus, minus, plus. What does plus mean for us?
Increasing.
Increasing. Very good. What does minus mean?
Decreasing.
Decreasing. What does plus mean again?
Increasing.
So our graph is going to be increasing. I don't know how. I don't know whether it's like this or whether it's like this. That's concavity. But I know it's going up.
Relative max.
Then I know it's going to be
relative
going down. Then I know it's going to be going up again. Right? Now, are these things relative maxes or mins? Well, that's a tricky question when you have a denominator because we don't know what's defined and what's undefined. You follow me on that?
Right.
So we're going to have to take a better look at that later on. We'll do the second derivative test right now. I'll show you how to combine those things, and then we'll start talking about curve sketching and what happens whether these things have asymptotes or not. Does that make sense? Now, I'm guessing that, can you actually plug in 0? You can, right? Yeah, 0. That is actually, that's a point, that's a defined point. Our slope's not defined, but that is a defined point. So if you plugged in 0, you're going to get a relative, what is that going to be when you're going up and going down? It's relative max. What's this one going to be? It's going to be relative min.
Yeah.
So that does
Is it?
actually work for us in this case. But I'm going to show you how to figure that out in association with the second derivative test. Let me get that pen. Do you feel okay with the first derivative test? What's the idea? Take the first derivative, set it equal to 0, find your critical numbers, and then plug in some values for every interval. That'll tell you increasing and decreasing. That's the whole plan. You follow? Now let's take a look at the second derivative test.
2 is relative min because doesn't make the denominator equal to 0. That's why I had to plug in 0 up there. $13 more.